So now let's talk about dependent sample or paired t-test. You're probably going to hear these more as paired t-test. So it's two mean paired t-test is usually what they call them. Again, I'm looking at two samples and I want to know, when I talk about two samples, I'm talking about the same individuals or objects are happening in these samples. So it's a different way of thinking. So think of it now. You're looking at one group of people or one group of objects, but you took two different samples of data out of those groups. Okay. So you've got to have simple random sample. Sample sizes are often small. The two measurements or the samples are drawn from the same pair of individual objects. The difference are calculated from the matched pair samples. So what does that mean? Okay, so say that I wanted to see okay, so let's do this. I have 30 students in my online stats class. I want to know what your average salary was before you started college. And I got your average salary. And then I wanted to know your average salary once you graduated with your degree and you'd been working for a year. So then I take your average salary after you graduated, and then I subtract your average salary before you graduated. And it's going to give me a number. That number is the difference between your two types of salaries. That's what I'm measuring. And again, it's the same group of students. I'm just looking at what's going on for one very specific part of data in two different times. So the differences form the sample, and again, I just explained that. And either the matched pairs have differences that come from the population that are normal, or the number of differences is sufficiently large so that this distribution of the sample mean of the differences is approximately normal. Okay. So again, we call this a matched or a paired or a dependent sample t-test. You'll hear it all different kind of ways. But the basic thing to think about this is you're looking at the same group of people, but you're looking at something in two different points in time. That's really how I think about it. We use this so much for teachers because we do those pre and post tests. We want to see what you're doing. If you've gone through some kind of program or something, you'll get usually a pre and a post thing. It's just a way for us to mark the difference that was made before something and then after something. Again, we're going to use a t-test statistic, and you're going to also get a degrees of freedom. Don't do any of it by hand. Minitab is your friend. All right, there is a difference in hypotheses. Okay, huge difference. So let's think about it. Again, I have a pre, I have a post. I want to find the difference between my pre and my post. So if you see here, let's look at left-tailed. So it's saying the null is the average difference is greater than or equal to 0. And the alternative is the average difference, is less than 0. Okay, so think about this way. If say your salary was $16,000 before you went to college, and your salary after when you went to college was $16,000. There's no difference. There's zero difference between the two of them. So the zero difference means nothing happened. It's the same as it was before, and it's the same as it was after. So that's what we're doing. We always compare things to 0. So right-tailed, the null is the mean difference is less than or equal 0. The alternative, the mean difference is greater than 0. Two-tailed, the null is the mean difference equals 0. Nothing's going on. The alternative is the mean difference does not equal 0.